Hello, and so today we're going to be going over lesson 10. So we're going to be using reasoning about rigid transformations to find measurements without actually measuring. Alright, so I'm going to start off by tracing my figure here. So if you need to pause and go ahead and do that, do that. Now it says reflect triangle ABC over line AB. And so when I do that, whatever the new image of C is, I'm going to label C prime. Okay, so I'm going to reflect this over so that AB is still on AB. And then right here is my new C point. Alright, so I'm going to draw that triangle here. Okay, so that's what we did, and we're labeling that C prime. Alright, now it says rotate triangle ABC prime around A so that C prime matches up with B. So C prime needs to match back up with B here, okay? I'm going to rotate and stop. So it lands back on top of each other. So it lands back on top of the original. Alright, now it says, what can you say about the measures of angles B and C? Well, what we can say is that they are the same. And we know that because if we were to rotate and use rigid transformations, put angle C on top of B, they match, okay? So that is how we know that. Okay. Now down here it says triangle, draw a point on here. So I'm going to go ahead and draw that. A, B. C. Okay, so draw a midpoint M on the side of AC. So what I'm going to do is fold my patty paper in half, fold C on top of A to get that crease where the midpoint should be. Labeling that M. It says rotate triangle ABC 180 degrees using center M to form CDA. Okay? So I'm going to rotate 180 degrees, so I'm going to land back on top of this line here. Okay? And boom. We land directly on top here. And I'm going to label this B prime over, or it said to label that D. Oops. Okay, so I label that new point D. So then here's my new triangle. And so now it says, what do we know about quadrilateral A, B, C, D? So we're looking at this shape as a whole now. Well, we can call it a parallelogram. Okay, so parallelogram, because these opposite sides are parallel. They will never run into each other, so we can call that a parallelogram. Alright, now what we're going to do is some rotations and reflections and translations to get all of these triangles to each other. So we're just going to read what it says and we're going to do it. Okay, so it says describe a rigid transformation that takes triangle 1 to triangle 2. And then what corresponding points correspond to the original. Okay, so let's use the information that we just did in our last activity and do it on this one. So if I'm going to from 1 to 2, I see that this side length matches up with this triangle side length. So I'm going to create a midpoint. So this is the middle of this segment, and I'm going to rotate 180 degrees on that midpoint and see if it lands on top of each other. And it does. So I'm going to say rotate 180 degrees at midpoint M. Now it says what points in triangle 2 correspond to A, B, and C. So I'm going to write C corresponds, or I'm just going to write an arrow. C goes to A, and then we can say that D corresponds to B, because if we put this over here, B now lands on D, and then A now is C. Alright. Now we're going to look at the second one. It says describe transformations that take 1 to 3. And then we're going to see what corresponding points are there as well. So let's try the same technique. So we're going to do a midpoint here. Or let's call it something else. Let's call it midpoint P. Okay. So let's rotate 180 degrees at this midpoint. And our triangles do land directly on top of each other. So rotate 180 degrees at midpoint P. Alright, so my original A, so A now lands on B. And then let's say our B now lands on A. And then our C lands on E. Okay. Alright, now it says find 2 pairs of line segments that are the same length and explain how you know. Okay, so let's look up here. We want to see line segments that are the exact same length, okay? Well, I can take this original one and see where they match up with. So let's take BC and see where this matches up with. So BC matches up with AD. And it also matches up with EA. So BC to EA. Alright, now we can do that with a different side length. So we can take AB here, and then we can move it around and see where it matches up. And it matches up with CD. So AB matches up with CD. Alright, now it asks for the angles, okay? So, let's start off with, let's label it angle C here. So, angle C, and then let's see where it matches up. Matches up there, so we could call it angle C matches up with, so we can't say angle A because we wouldn't really know which one we're talking about. So let's say CAD. Okay, so then we know it's talking about angle CAD. So this angle here. Alright, so that's a good one. And then okay. Now one more. let's look at angle. Let's do angle. Let's do angle A. So our original angle A. Alright, now let's see where this matches up. And it matches up down here. So we can call this angle EBA. So I'm going to write that down there. And the reason why we know they are the same length is it's proven through our rigid transformations, because they land directly on top of each other without being changed. Okay. Alright, on to the last one here. So what we're going to do is just follow these instructions and see what we find out. So right here it says reflect triangle 1, in a way, ONE, across line segment ON, and then label that new point M, okay? So I already have mine traced, so go ahead and do that. And I'm reflecting on segment ON here, okay? So I'm going to reflect, and my new point here, I'm going to label M. Okay? So, there we go. Labeling that M. So it says, what is the angle measure of MON? So what is that angle measure? Well, if we took this angle measure we know right here to be 30 and moved it here, wouldn't this be 30 as well? So we're going to write 30 degrees because that did not change there. So now it asks us, what is the measure of MOE? Well, it would be both of these angles combined. So 30 plus 30 is 60. Alright, now it says reflect MON across OM. Okay. And there's our new point. And I'm going to label that T. That says, how long is OT? Well, OT right here, I can see is 5. It's the same length as our original ON. Alright, and then it says, what is the angle measure of, down here, it says, what is the angle measure of TOE? So if I look up here, TOE, well, we're going to say this is the exact same angle, so that's another 30 degrees. So 30 plus 30 plus 30 gives us 90 degrees. Now, lastly, it says if you continue to reflect each new triangle this way, what will that pattern look like? So if that just kept happening, we would just have triangles reflected around point O. So it would just continue, and we would have these triangles just reflecting, and then they'd all be centered around O. So that is all for today. But make sure you read the summary, and have a good one.